Hi everyone, I'm Davidson Sega, graduate student at Carnegie Mellon University. In this video, I'm going to introduce you to how ClearML can provide great machine learning operation support to your machine learning problem. The agenda of this video is as follows. We shall discuss the machine learning problem we were trying to solve. I will introduce you to ClearML and what it will bring to our team. I will illustrate how the tool is useful in a production machine with evidence that the tool was tried on data from a movie streaming scenario. Lastly, we'll talk about the strength and limitations of the tool. So imagine you're a team of 5 solving machine learning problem. In this case, I will take the example of a movie rating prediction problem. Let's think about how the data is coming to us. First, the movie ratings information is collected on devices by the users. It is moved to cloud and structured well. We will download the data to our system and analyze, process, and prepare the data for prediction. The idea is simple. Machine learning models will take this data and learn how to predict the rating if a particular set of features were provided to it. Features here are the demographics of user and movie details. It will give us the outcome prediction of 1 to 5 stars. Here's an example of how the data I'm using will look like. The data was downloaded and processed from the Kaggle link provided below. In general, machine learning engineering model building has multiple phases. As you can see, model building, evaluation, productionizing, testing, deployment, and monitoring require multiple codes, models, and data to be structured. So we need version control and process control across all these aspects. The challenge that often occurs that when many coders and stakeholders work together, it causes chaos. In order to control the movement of information and structure our workflow, we utilize ML operations tools. ClearML is a MLOps tool for efficient productionizing of ML workflows. It has many clients in the Fortune 500 space and is growing rapidly. Their mission is to accelerate ML adoption, making ML seamless to integrate into any software and hardware product out there. This tool will help data science and ML teams to orchestrate and automate ML experiments and workflow easily. Here's a look at the harmless looking UI. It's very intuitive to understand and easy to navigate. Now we shall look at how to integrate the ClearML tool to our movie rating prediction problem. I've created a GitHub repo with an example to help you run the codes alongside me in this video. You can pause the video and download for clone or fork the repository for your convenience. Now let's look at the repository. Here's the codes which you can find and all the README associated with it, initialization settings. So you can basically start with a Conda install and activate it. And then once you activate your Conda with the correct version of Python, you can install the requirements which I've already given to you. And finally, you can initialize the ClearML, which is the most essential step. So once you initialize it, it'll ask you to go to a certain link where you can log into ClearML, and it'll ask you to paste certain key and value so that ClearML can recognize that the online UI, which is here, is related to this particular device. So after you've initialized the ClearML and if it's started running, you just have to come up to this dashboard and you can run all your codes from the model training notebook, which I have made for you. So this is a temporary notebook. It's just for example purposes. I've basically just taken a model training example of movie prediction and incorporated ClearML MLOps to it. So in this notebook, we are just starting by connecting to ClearML. And once you connect to it, it automatically uh, starts looking into the whole notebook at once. And then everything you do from that point will be logged, and you can access the logs from the app as well. So this is the first starting point where you connect with a project name and task name, and that corresponding project and task will get created. For example, this was random forest V1 on data 1, which I have it here. And now I'm reading some data from my repo. And then also we can also do version control of data itself, which is very important. So suppose you are 5 different people working on 5 different data sets. So the versioning of data can be very well done through ClearML. As you can see here, dataset 1 and 2 are separate. And this way, team members are better able to identify and also easily download the datasets whenever necessary. So we look at the dataset, we perform some analysis. So ClearML also takes down the analysis plots provided. In this case, I'm working with scikit-learn and matplotlib. So all the models created with scikit-learn are logged directly. So I'm utilizing this joblib library, which essentially takes the model and dumps it into one single pickle file. And this pickle file can later be downloaded from ClearML, or even it is also logged in ClearML. So I can show you how that looks like. So all the artifacts, all the models are stored separately as models. Since this is just a scikit-learn model, it doesn't have a lot to show. But if it were a deep learning model with a complex architecture, you would be able to see the model configuration in it very clearly. So looking at the experiments, I ran uh, this model training code on random forest, and random forest was run with these parameters. So for this task, I have set these parameters, and these parameters are now logged into my project, and I can look at them through in configuration general. So here we can see the criterion was used as entropy 20, auto 60, etc. So you can actually keep the configuration of the task, and you can have multiple tasks running by different people, and you can actually compare 2 different tasks at once, which is, I think, my favorite feature. You can look at the hyperparameters of how they've changed. For example, max depth was different. It's highlighting that, and criterion and max features are more or less same. We can also look at scalars. So this is basically how across iterations fit time increased or decreased, or test accuracy decreased across different uh, models or different experiments. So you can compare experiments, and you can see different uh, attributes of the model performance or experiment performance. It also stores all the plots which were generated throughout the model building procedure. So I specifically noted down these plots, which show me that the right side model doesn't perform very well, but the left one is pretty good. So it's more or less this. You're able to very well orchestrate the whole process of model building. And also, you can also do this in productionized environment where, for example, if you have a model which is running and is constantly storing data, so you can actually use this scalars um, column, and you can store the graphs for um, different things, for example, hit rate or um, the inference time of the model, and see how the model is performing live. And lastly, now we shall go through the strengths and limitations. So the strengths and weaknesses of this ClearML process is that uh, ClearML has larger benefits than weaknesses. It's very easy to understand, integrate, and works well with most codes. It also is 100% open source. That means you can Dockerize the app in your system for free. The few weaknesses are regarding the lack of support to R and sklearn libraries, but I'm sure that the community might find ways to bridge that gap too. So that's all about ClearML. It's a great tool and can help you improve the dynamics and results of an ML project. Do try it. For any questions, please feel free to contact me via LinkedIn or email.